Okay, kids, pause. Let's turn around here. So those of you that did u equals cosine, you can lead me through this. So you said u is equal to cosine theta. So what did that make v prime equal to? What did it make it equal to? Cosine theta d theta? Oh, you can't see what I'm doing. Thank you for doing that and not letting me continue. Okay, excellent. So what does v prime equal then? Sorry, what does u prime equal? Negative sine theta. And what does v equal? Sine theta. So we now know that if we're going to take this and use the really cool statement we have for integration by parts, it's u times v at the beginning. So what is it? Cosine theta times sine theta minus u prime v, right? Negative sine theta what? Times what? So then what? So that means we have cosine theta sine theta plus the integral of this, right? And there's a d theta right there, right? So at this point you're like, huh, we're kind of back to where we started, right? Are we kind of back to where we started? Yes. Kind of, maybe, sort of? Yeah, so then maybe you tried sine and did it really go anywhere? Did you try, maybe at this point, did anybody try integration by parts on this right here? What did you try, Brenna? So you said u was sine theta. That's not sine, I can almost write. Nice. So you like this, and then you did what? V prime is sine theta d theta. So what does that mean v is? Negative cosine theta. And this is u prime is going to be cosine theta. So now you know that this right here is going to be equal to u times v, which is negative what? Sine theta cosine theta minus what? The integral of cosine theta times what? Negative cosine theta d theta. I kind of see where you're getting at here. So we did that. So let's just write out what we have. We now have this right here, cosine squared d theta. I'm just bringing that down right there. And that's going to equal, bringing this down, cosine theta sine theta minus what? Sine theta cosine theta plus what? Plus the integral of cosine squared theta d theta. What happens? You get 0 equals 0. Is that a very helpful thing? No, it's not a very helpful thing. So I totally agree that you could do some correct mathematics. Can you tell me, so you asked the big question, someone asked it over there, what does it mean when you get 0 over 0? It can mean a couple things. It can mean either that everything is a solution. It could mean that everything is a solution, but the thing is, there's no equal sign in this, right? We got 0 equals 0, right? Do you remember when you first did systems of not linear inequalities, systems of equations? What happens if you plug an equation into itself? Do you know what you get? If you plug an equation, remember substitution? When you learn substitution, you isolate y and then you substitute it into the other equation. Do you remember what happens when you substitute an equation into itself? Anybody remember? This is what happens. You get 0 equals 0. So sometimes the information is in effect like too helpful. Nothing's wrong with this, but I want to offer another method. So we got to here. We got to here right here, and we're like, okay, that's nice. That's kind of cool. And what did we do? We cleaned this up a little bit, right? What did we do to this? We made it, it's cosine theta d theta squared equals cosine squared sine theta plus this, right? Correct? Yes. Oh, okay. Question for you. You remember doing all that trig and pre-calculus? What is sine squared? See, the integral of cosine squared theta d theta equals cosine theta sine theta plus the integral of what? 1 minus cosine squared theta d theta, correct? Is that correct? Yeah. What can you do when you do the integral of two things being subtracted? Separately, so what does this equal? Cosine theta sine theta plus the integral of d theta minus the integral of squared theta d theta. I don't want to drop the theta. Oh, I could bring it to the other side. Now I can make it 2 times the integral of cosine squared theta d theta is equal to cosine theta sine theta plus what? Theta. And now what do I divide both sides by? Oh, look at that. Cosine theta d theta is equal to 1/2 of cosine theta sine theta plus theta. Okay, sit down. Took a trig identity and what is this called? Turning that into that. What's that called? Substitution. This is trig substitution. This right here is one specific trig substitution we did that allowed us to relatively cleanly, like, is the algebra in this very difficult? No. Is the methodology kind of annoying? Yes, because yeah, that right there is the magical thing, but the other magical thing is that, yeah, you're still stuck with this, but look, it pairs up so nicely over there. That's a really cool trick. So there are basically two tricks that you need to remember for integration by parts. Sometimes you have to do parts more than once. And we did that yesterday. Remember, it got rid of the x. We did it the wrong way before. It got too big. We went from x squared to x cubed. We wanted to go down. Once we went down, it like went away. And when we got to like sine theta and we were done, we can integrate that. Another thing to look for cute substitutions. It's really annoying. That's a cute substitution. Oh, sine squared. It doesn't seem like it's that helpful though, right? On the outset, going from this to this does not seem initially that helpful unless you have seen something like this. Oh, look, it turned into a 2. Is it overall super helpful? Yeah. Yeah, it is. Please put everything away except the pencil. Let's disassemble it. No, it's not super clear, but let's disassemble it. You've seen certain words in there before. Use something to express something in terms of something else. Like you've seen it maybe like express y in terms of x, right? For example, y is now expressed in terms of x. Y is written in terms of x. Exactly. So they want you to use integration by parts to express this in terms of this. So this is y in terms of x. Y in terms of x. Any thoughts? It's asking you this in terms, so this right here, you can consider this to be your y. You want that to equal something, something, something with this on the other side, correct? That's what it's asking you to do. So what it's asking you to do is you're taking this, x cubed e to the x dx, and you know that's going to be u times v minus u prime v, correct? You need to make, x squared, sorry. You need to make choices for your u and your v so that when you turn it into this integral is the one that goes right there. That's what you're trying to do. That's what you're trying to do at least. Does anybody have an idea as to what we could choose for u and v in this case? Well, there's a hint here. We're going from x squared to what power? X cubed. So x squared better go up. So we need to we have u and v prime. So which one is going to be v prime? X squared, like dx. So what's that make v? 1/3 x cubed. So if that's x squared, what does u have to be? So what does u prime have to be? E to the x dx, correct? So now if we use this substitution, what happens? What's u times v? 1/3 x cubed e to the x minus the integral of what? U prime v, which is going to be e to the x times 1/3 x cubed dx, correct? What can we pull out there? So we know that this e to the x dx is equal to 1/3 x cubed e to the x minus 1/3 the integral of what? E to the, let's write it in the right order here, x cubed e to the x dx. So what have we done? We now have this written entirely in terms of that. What they're trying to get you to do in this case is, if you make this substitution, it gets you here. You have generated this piece here. You've generated this piece. Now it's asking you to do this and go down. You can make a different substitution. What's the other substitution you can make? You can make u equal to what? X squared, and therefore u prime is going to be 2x. And is that getting the power you want right there? Yeah, there's going to be a coefficient up front, but you have written the integral you want. This is your y in terms of x. Y, blah, 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 and the only thing that you don't have is this. That's okay. Basically, when they're saying in terms of, you can have this in the answer. You can have this in the answer. So do you substitution have this left, is what they're asking. They're just pointing out, one of them goes in the direction you want. This one goes in the direction you don't want. Why is this the direction you don't want? That 3, what happened to the power? Remember yesterday we did this and the power went up? Is that what we want to have happen? Not generally. You do it once and you get to here, then you're like, oh, what do I have to do one more time? You do one more parts, exactly. And then what happens to that x? It goes to 1, and then you're left with just e to the x. You'll have some coefficient out front, but it goes away. It goes away. They're just pointing out one direction it gets worse, one direction it gets better. And I have tied Dan Savage into my BC calculus class. I think of this as like a welded thing, like it's longer, but like you can't break it up. You don't have any choices, right? Can you break it apart like the 7 is? No, you have 2 things in here, right? So there's really only 2 choices for u substitution, right? Here's the first thing, here's the second thing. There's nothing else you can do. So you let u equal this and b prime equal that. Why do you let u equal this and b prime equal that? Because you know the derivative of this. You know the integral of that? No, you really don't. You also, do you know the integral of this? Yeah, you really do, right? So it's a really nice setup. It's not that bad because when you take the derivative of this, remember what it is? The derivative of arctan? 1 over 1 plus x. Yeah, I'm just checking this again. 1 over 1 plus x squared. It's not x. What is it going to be? It's going to be 7. You have to be very careful about this because when you do the derivative, this is the one thing I will say. What is d dz of tan inverse of 7z? That's 1 over 1 plus 7z squared times what? 7 times 7 because of the chain rule. Just be careful. Just be careful.